All right, so for a hydroxide, for number one, what happens when I heat a hydroxide? I get water, right? So that's one product. What's the other product? Very nice. You get a metal oxide. In this case, it would be copper oxide.
Wow, I got that right.
Very nice. So look, let's just make sure we get this formula correct, okay? I want to make sure this formula is right. When I make a new bond between copper and oxygen, I think about their oxidation states. So for example, oxygen I know has a 2- oxidation state, right? So how many coppers will I need? 2. So I'm crisscrossing that number. I'm putting that down here. That's how many bonds copper is going to make to oxygen. There's going to be 2 coppers required. How many, what's the oxidation state of copper? Do we know?
No, it's a metal.
It's a transition metal, right? So it doesn't have a fixed oxidation state. But I can get that from here. This chemical right here, copper hydroxide. How come I needed 2 hydroxides?
You need 2 coppers.
Because it's a 2+ oxidation state. So I'm going to use that same oxidation state on this side. There's a 2+ oxidation state on copper.
So it's 2 2.
So I need, exactly. So I need 2 oxygens. I crisscross that number. So if it's 2 and 2, that's 1 to 1, right? So I don't write anything. The finished formula is just copper oxide. That's finished. Make sense? Okay. What about number 2? Nitrate, and we got copper nitrate and sodium hydroxide. What type of reaction is that?
Double.
That's a double replacement reaction. Good. What about the first one? What type of reaction was that? A decomp, exactly. That's a decomposition reaction. What about number 3? What type of reaction is that?
Singular.
Single replacement reaction. Very nice. So for number 2, what are the products? John, what do you think?
Like what do you get?
Yep, what do you get?
You get sodium nitrate.
Sodium nitrate, perfect. And what?
Copper oxide.
Copper hydroxide, right? How many hydroxides do you need?
Oh yeah, copper. 2.
Absolutely 2, exactly. Because again, the oxidation state of copper here is 2. Perfect. Which one of these is there one that's aqueous? These products?
First one.
Has sodium.
Yeah, nitrate's aqueous, right? Nitrates are always soluble. And what about copper hydroxide? Are hydroxides usually soluble?
No.
They're not. They're insoluble. So this is actually a solid. Cool. Can you decompose a solid?
Yes.
Yes, right? We decomposed in the lab. We took solid copper carbonate and we heated it up. We produced CO2, right, from that. So for this single replacement, what happens there? Number 3.
You get aluminum chloride.
Nice. So aluminum will replace hydrogen if it's reactive enough. You look at your reactivity series, and it is reactive enough. So you get aluminum chloride. How many chlorines do you need, Devin?
2.
3, because it's in group 13. Aluminum's in group 13, right? Makes 3 bonds. So then what's the other one?
H2.
Nice. Hydrogen gets kicked off. It's by itself, but hydrogen exists as a diatom. It will bond to itself as it leaves. So you get H2 gas. Is that explosive?
Yes.
Yes. And then number 5, you got copper oxide. Are oxides soluble?
No.
They're not. That's why it says solid right there. That's why that's solid, because oxides are not soluble. Then you have hydrochloric acid. What type of reaction is this?
Double.
This is a double replacement reaction. So what are the products? Yusuf, what do you think?
Hydrogen. Hydrogen oxide.
Yeah, what is hydrogen oxide?
Hydroxide.
Water, right?
Water.
Dihydrogen oxide. An oxide of hydrogen is just water.
And then
What's the phase on water? Liquid or aqueous?
Liquid.
Liquid, very good.
And then copper chloride.
Copper chloride. How many chlorines do you need?
2.
2. And what's the phase on a chloride usually?
Aqueous.
Aqueous, very good. Chlorides are soluble except silver, lead, mercury. Just those 3. Does this make sense to everybody? Everybody on the same page here? Okay. So what you have to do now is work on those 4 reactions. I need 4 reactions before the end of the day that are going to take you from copper nitrate, this blue solution. You have to use, in your reaction series, you have to use hydrochloric acid, and you have to use sodium hydroxide, and you also have to use aluminum, metal. If the product of your last reaction has to be metal by itself, which one of these 3 types of reactions, decomp, double replacement, or single replacement, is going to do that? Single replacement. You see this third one right here, number 3? See how that metal is all by itself? That's the idea. If you want a metal all by itself, you have to do a single replacement. Is a single replacement something that happens in water, or can I use a solid?
No. You can use
It has to be in water. This is an aqueous reaction. This happens in water. That's why I started with hydrochloric acid and I added this metal. It has to happen in aqueous solution. So if I have two solids, can I do it?
No.
No. Can't do a single reaction. Single replacement reaction. So this has to be the last. This is going to be the last thing in your procedure. This is the last reaction. It's going to be a single replacement in type, right? The metal produced will be copper, right? And this thing right here, whatever that is, that has to be aqueous. Whatever this ends up being in that reaction has to be aqueous, because it's a reaction in solution. Does that make any sense so far? Okay. The first reaction in your series is going to be copper nitrate as a reactant. This is going to be the first thing that happens. Copper nitrate plus something. That's going to be the first reaction, right? So you might think of it like this. This is your setup for your competency. You're starting like this. This might help people who are just completely stuck right now. The first reaction, as a reactant, you're going to have copper nitrate plus something yields something and something, right? You're going to have a second step and a third step and a fourth step. We know this one has to be a single replacement, and then the product is going to be copper solid plus something else, right? Something and something. And there has to be a decomposition reaction, so one of these three has to be a decomposition. How am I going to do the decomposition? Heat. Specifically, I'm using the water bath, right? So right here, you also have to use a water bath. That's where it comes in. So the water bath is for decomposition. Okay? Does that help? All right, get to work. Work in your lab groups. Ask good questions. If you're already done with the 4 steps, take a peek at this and make sure you're getting all the points you're doing. One would be make the reaction your own, do something unique, maybe make it happen in one step, go from copper nitrate to solid copper nitrate.
What are you supposed to do it for?
Right, so that's the reaction. The one that you're going to do this reaction on your own. Like, any way you want to, any reactions you want to start with copper nitrate, just as a written reaction. That's what the Google doc. It's like a little further thinking. It's creative, right? And the other thing I want you to try to do is think about this gas production machine. There's gonna be some gas produced. I want you to think about what that could possibly be. Let me just stop real quick.